Our goal today is to talk about the sleep cycle. So every night when you go to sleep, your body is going to descend through stage 1, stage 2, stage 3 of what we're going to call non-REM sleep, and then back up from stage 2 into REM sleep. You don't go into REM sleep, which is when you dream, until about an hour and a half into your sleep cycle. And you notice that on an average night, you're probably going to cycle through these stages about 5 times. And look at what happens to REM sleep as you cycle through. You see how it increases as the night goes on. It's really important to get 7 or 8 hours of sleep, because you see that if you're depriving yourself of those last few hours, you're really losing a lot of REM sleep, which we're going to learn is really important for things like memory consolidation. If you are ever woken up by someone and you feel super groggy, you kind of wake up and you don't know where you are, it might be because they've woken you up during this non-REM stage 3. We're going to learn that our brain waves are really, really slow during this stage, and we're not meant to wake up during this stage. If you are, a good indication that you're getting enough sleep is if you're waking up in the morning without the need for an alarm clock. If you're waking up on your own without the need for an alarm clock, you're actually probably remembering what you're dreaming, because you're waking up here right after you've been in REM sleep. We're going to distinguish between REM sleep and non-REM sleep. REM sleep refers to rapid eye movement sleep that begins about 90 minutes into the sleep cycle. You might start off in REM for about 10 minutes, but again, every time you go into REM sleep during the course of that cycle, the period of REM gets a little bit longer and longer. REM sleep is linked to memory consolidation. So researchers believe that REM sleep actually helps us kind of clear out our memories. During that period of time, our brain is busy consolidating or storing important information that we took in that day and getting rid or pruning out the stuff that's unimportant. And they know that REM sleep is important for memory consolidation, because if they teach someone something, or even teach a rat, let's say, how to run a maze, and then deprive them of sleep that night, they have more difficulty remembering what they learned the day before than in situations where they're allowed to get the full amount of REM sleep that they need. During REM sleep, your brain waves are actually very similar to when you're awake, but the brain waves don't exactly look the same, and we'll look at that in a little bit. REM sleep is sometimes referred to as paradoxical sleep, because it's when we're having very, very vivid dreams. Our brain is very, very active with this visualization process, but yet our voluntary muscles are paralyzed. So when you're in REM sleep, you're unable to get up and move around. You might open your eyes, and you can move your eyes around. Maybe you're like me, you've experienced something called sleep paralysis. Sleep paralysis is when you wake up in the midst of REM sleep when your voluntary muscles are still paralyzed and you're able to open your eyes, but you're unable to move. So for that reason, it's sometimes called paradoxical sleep. And think about the muscle paralysis this way. From an adaptive standpoint, it would be a survival advantage to not get up and act out your dreams. Think about our ancestors, wandering out of their caves in the middle of the night, acting out their dreams and being eaten by a large animal. Really interestingly, infants spend about 50% of their sleep in REM sleep. We're going to look in a second at the differences in sleep across different age levels, and that is a very interesting point. Non-REM sleep are stages 1, 2, and 3. During this time, the body's repairing itself, tissues regenerating, our immunity is being strengthened. Deep sleep happens during this stage 3 sleep. I want to point out that if you are a sleepwalker, this is known as somnambulism, or if you're a sleep talker, those are not happening during REM sleep. It's a common misconception that people sleepwalk during REM sleep or while they're dreaming. As I just explained to you, that's impossible because your voluntary muscles are paralyzed. So sleepwalking and sleep talking actually occurs during stage 3, non-REM sleep, when your brain waves are very, very slow. There are individuals who have what is called REM sleep disorder, where their muscles are not paralyzed when they're in REM sleep. So they actually may get up and act out their dreams, but that is definitely not the norm. REM sleep deprivation. So let's say I'm really sleep deprived. I'm not getting my full night's sleep. Therefore, I'm denying myself a lot of the REM sleep that occurs at the end of the sleep cycle. That leads to what we call REM rebound. Pay attention on a Saturday morning when you don't have to get up with an alarm clock. See if you remember more of your dreams. There's a couple reasons for that. It could be because you're experiencing longer and more frequent periods of REM sleep because you've been sleep deprived during the week. It also could be because, like I said, you're waking up on your own without the alarm clock. And we naturally wake up on our own right after that period of REM sleep ends. Sleep debt accumulates. You cannot pay off your sleep debt, which is even more the reason why you have to make sure that you are getting an adequate amount of sleep. So this is just another peek at the sleep cycle. Now you can see a little bit more of what we talked about. REM sleep are non-REM stages 1, 2, and 3. Here you can see what a sleep cycle might look like for a young adult versus someone who's elderly. It's a common misconception that older people don't need as much sleep as younger people, but that's not in fact true. They still need to get 7-8 hours of sleep. However, they tend to get less sleep, or at least less quality sleep, than younger people do. And you can see that because they're waking really frequently during the course of the night. And they're also experiencing much less REM sleep because they're constantly restarting the sleep cycle. They're also getting less deep sleep than young people do. Note this chart's a little bit outdated because it's showing you stages 3 and 4. As of several years ago, these stages have been combined so that it's now just called non-REM stage 3. As we were saying earlier, newborns spend a tremendous amount of time in REM sleep. They can sleep 16. Actually, I have a newborn niece who was born premature, about a month premature, and I was reading a little bit about the sleep cycle of preemies, and they can sleep up to 22 hours a day. They do tend to wake every hour, but when you add up the amount of sleep they get, it's just really remarkable how much sleep they get. And you can see as well that newborns spend about 50% of their sleep in REM sleep. So they spend about 50% in REM sleep and about 50% in non-REM sleep. You can see that the amount of REM sleep that we get decreases considerably as we age, whereas non-REM sleep decreases but not quite as sharply as REM sleep. So an EEG, or an electroencephalography, is a device that is used to record the electrical activity of the brain. So an individual who goes in for a sleep study would have a cap put on their head that is filled with these little electrodes that get attached to the scalp, and it's going to essentially be measuring the action potentials that are taking place in their brain, the electrical activity in the brain. This is what it might look like if someone is having a sleep study done. So when we are awake, this is what our brain waves look like. They're called beta waves, and they're very active. You'll see that our brain is still pretty active when we're in REM sleep as well. The electrical activity is just a bit more irregular than it is when we're awake. Alpha waves are drowsy waves, so as we're drifting into sleep. In stage 1 sleep, which is the first stage of the sleep cycle, we experience theta waves. And then in stage 2, at this point, we're pretty much asleep. Like, we can be woken up, but we're sleeping at this point. We experience random bursts of electrical activity called spindles. Spindles are really important because scientists have shown that spindles, these random bursts of electrical activity during stage 2 non-REM sleep, are associated with learning and memory. Similar to the research that I talked about with REM sleep, scientists have discovered that when they deprive an animal or an individual of stage 2 sleep of these spindles, that they also have difficulty remembering things that they learned the day before. During stage 3 sleep, non-REM sleep, we experience these very slow delta waves. This is when we are not meant to be woken. If we're woken during non-REM stage 3, we're likely to be very tired and very groggy. A way to remember: beta, alpha, theta, spindles, delta. Be a thankful, smart dude. There's your acronym. So if you needed any other reason as to why it's so important to get enough sleep, here it is. If you spend your day in school attempting to learn and then deprive yourself of sleep at night, it is very, very likely that you are being completely counterproductive. I always tell students it's better to spend an extra hour sleeping than to stay up an extra hour studying at night. Here's a quote from a National Geographic article from just a couple years back about sleep science in the era of screens, which is obviously where we are right now. Sleep reinforces our memory so powerfully, not just in stage 2, where we spend about half of our sleeping time, remember that's the spindle stage, but throughout the looping voyage of the night, that it might be best, for example, if exhausted soldiers returning from harrowing missions did not go directly to bed. To forestall post-traumatic stress disorder, the soldiers should remain awake for 6 to 8 hours, according to neuroscientist Gina Poe at the University of California, Los Angeles. Research by her and others suggests that sleeping soon after a major event, before some of the ordeal is mentally resolved, is more likely to turn the experience into long-term memories. So, again, this is just showing the really, really important role that sleep plays in memory consolidation. And if you're spending all day in school learning and you're up studying at night, don't deprive yourself of the ability to sleep and consolidate those memories.